Forget everything you thought you knew about scary math classes. Today, we're not doing homework. We're cracking a code, a secret code that lets us measure distant planets, design incredible video games, and build entire cities. We are talking about trigonometry.
So, let's just dive right in with a question. How on earth would you figure out the height of a massive skyscraper without actually climbing it? Or the distance to a star that's light years away? I mean, it sounds impossible, right? Well, this is exactly the kind of problem we're going to solve today.
Because at its very core, trigonometry isn't just a jumble of formulas to memorize. It's a kind of mathematical detective work. It gives us the tools to find the unknown, to measure what seems totally unreachable, and really to understand the world in a profoundly new way.
So, where do we even begin? Well, the secret is actually hiding in plain sight. It's right there in the name itself. It's all about the secret power of triangles.
You see, the word trigonometry comes from two Greek words, trigonon, which means triangle, and metron, which means measure. That's it. That's the whole game. It's literally triangle measuring. The entire field is built on this really predictable, totally unbreakable relationship between a triangle's angles and the lengths of its sides.
And to start measuring, we're going to need a toolkit. Our main tool, kind of like the Swiss Army knife of trigonometry, is the right-angled triangle. That perfect 90-degree angle it has gives us a super stable foundation to build everything else on. First, let's get to know its parts.
First up is the hypotenuse. This is the big one, okay? It's the longest side of the triangle. Its position is always locked in, sitting directly opposite that 90-degree right angle. It never moves, it's always there.
Next, we've got the opposite side. Now, unlike the hypotenuse, this side's name totally depends on your perspective. It's always the side that's directly across from the specific angle you're focused on, an angle we usually call theta.
And finally, there's the adjacent side. Adjacent just means next to. So this is the side that's touching your angle of interest that isn't the hypotenuse. So remember this key difference. The hypotenuse is always fixed, but the opposite and adjacent sides, they're relative. They change depending on which angle you're looking from.
Okay, now that we know the parts, it's time to unlock the code that connects them all. And don't worry, this isn't some complex, crazy password. It's a simple, elegant little phrase that holds the key to everything.
SOHCAHTOA. Yeah, it might sound like some kind of strange chant, but I promise you, this is the secret code that mathematicians have used for generations to solve all kinds of triangle mysteries.
Let's break it down. Sine, cosine, and tangent are just fancy names for three fixed ratios. SO tells us that sine is the opposite side divided by the hypotenuse. CAH means cosine is the adjacent side over the hypotenuse, and TOA means tangent is the opposite side over the adjacent. That's all they are. They're just recipes.
And this is a brilliant way to think about it. A right triangle with a 35-degree angle will always have the same ratio between its sides. Always. It's just like a good cookie recipe. You always have a fixed ratio of flour to sugar. And your calculator? Well, it's just a cookbook that has already memorized all the recipes for every possible angle.
All right, enough theory. Let's get our hands dirty and put these new code-breaking skills to the test. Time for our first mission. Let's see how this all comes together. Okay, here's the scenario. We're standing 47 feet away from the base of a really tall tree. We look up to the very top, and the angle of our gaze is exactly 35 degrees. Our mission is to find out just how tall that tree is without ever leaving the ground.
And we can solve this with a simple four-step method. Step 1, just visualize the problem. Draw it as a triangle. Step 2, label the sides from the perspective of our 35-degree angle. So the unknown tree height is the opposite side, and the 47 feet we measured is the adjacent side. Step 3, we choose our tool. Which part of SOHCAHTOA uses opposite and adjacent? That would be TOA for tangent. And finally, step 4, we just set up the equation and solve it.
So we set up our equation. The tangent of 35 degrees equals the opposite, the height, divided by the adjacent 47 feet. We do a little rearranging, punch it into a calculator, and boom! The tree is about 33 feet tall. Mission accomplished. Without taking a single step up a ladder, we just measured the unreachable.
But you know, this isn't just about measuring trees. This exact skill is the hidden engine powering our entire modern world, from the games on our screens all the way to the stars in the sky.
Have you ever wondered how your character in a video game can aim so perfectly? Or how a thrown object makes that perfect, beautiful arc? Yep, that's trigonometry, calculating all those angles and trajectories millions of times per second. And how does your phone know exactly where you are at any given moment? The GPS system uses a method called trilateration, which is basically a fancy 3D version of triangulation, to pinpoint your location based on signals from satellites orbiting the Earth. It's amazing.
And on an even grander scale, astronomers use this exact same logic to measure the distance to stars. They observe a star from 2 different points in Earth's orbit, creating this massive triangle, and they use the tiny shift in the star's apparent position to calculate its distance. Mind-blowing.
I mean, as you can see here, the applications are pretty much endless. This mathematical language is absolutely essential for architects designing our buildings, for pilots navigating the skies, and even for music producers who are analyzing sound waves. It's a truly universal tool.
So let's totally reframe how we think about this. Trigonometry isn't just a list of abstract rules to memorize for a test. No way! It's a creative toolkit that lets us build, navigate, and explore our universe with precision and with confidence.
And this isn't some ancient, finished subject. Math is a living, breathing field. In fact, just recently, 2 high school students did what professional mathematicians thought was impossible for 2,000 years. They found a completely new proof for the Pythagorean theorem using trigonometry. It just goes to show you that anyone can make a discovery.
Because that's the real power here. Trigonometry isn't the end of a lesson, it's the beginning of a new way of seeing. It's a doorway to asking bigger, better questions. So the only question left really is, what will you measure?